Everyone is talking about a chip reportedly designed in 48 hours. But did everyone miss the real story? A reported AI-assisted chip design workflow completed in about 48 hours became one of the biggest semiconductor headlines of the year. But was the reported timeline really the biggest story? The announcement attracted worldwide attention and even influenced semiconductor-related stocks. Markets rarely react to engineering demonstrations alone. So what exactly captured everyone's attention? Forget the 48 hours for a moment. Instead, look at what made the workflow possible. AI, mature open-source EDA, commercial chip design workflow. That combination may be far more significant than the reported engineering timeline. While AI was transforming software engineering, semiconductor researchers and educators had already begun exploring a different question. Could AI make commercial RTL engineering easier to learn? The biggest obstacle was never learning Verilog. The real challenge was the cost of commercial EDA tools and the practical laboratories needed to use them. When practical laboratories become expensive, education naturally shifts toward theory. Students learn HDL languages. Far fewer experience the complete commercial RTL engineering workflow. Researchers began combining AI with mature open-source EDA, not to replace commercial EDA, but to reduce the expertise and infrastructure barriers needed to learn professional RTL design. The reported 48-hour workflow did not create this idea. It simply brought worldwide attention to a direction that many researchers and educators had already been exploring. If commercial RTL education becomes less dependent on expensive proprietary infrastructure, practical semiconductor training could become accessible to far more institutions. That changes the economics of semiconductor education. India has thousands of engineering colleges and millions of engineering students. Lower educational barriers could significantly expand access to commercial semiconductor education. The opportunity is not AI designing chips faster. The opportunity is preparing many more RTL, FPGA, ASIC, and verification engineers through accessible, workflow-oriented education. Before the recent AI-assisted chip design announcement attracted worldwide attention, educational initiatives based on this philosophy were already underway. One example is the Udemy course, Commercial RTL Design Using AI. Learn what industry needs. Together with the accompanying Medium article, AI plus open source EDA, can every Indian engineering college now teach commercial RTL design? Together, they document a complete AI-assisted commercial RTL engineering workflow, from engineering requirements and AI prompting to RTL design, verification, synthesis, technology mapping, and engineering documentation using mature open source EDA tools on an ordinary laptop. Rather than introducing a new idea, they provide a practical example of the educational direction that the recent announcement has independently reinforced. The future is not simply learning Verilog. It is learning the complete commercial RTL engineering workflow with AI as an engineering assistant. The reported 48-hour chip design workflow may eventually be remembered for something much larger than its timeline. It may mark the moment when AI and mature open-source EDA together began reshaping the economics of commercial semiconductor education.